So, picture this. You are deep in a late-night coding session, right? You've got your coffee, you're looking at the current state of modern AI alignment, and you are just trying to figure out how to fine-tune a model for your own specific application.
Yeah, a super common scenario these days.
Right, but as you're digging in, you realize something completely wild about how this used to work. Like, the industry standard used to require standing up 4 massive separate neural networks,
4 of them, all at once.
just constantly arguing with each other in memory, literally just to train one single model. I mean, it was an absolute architectural nightmare, but today we are doing it with one model.
It's honestly a massive leap.
It really is. So, welcome to the deep dive. We are looking at a stack of notes today on modern AI alignment methods, and specifically, we're tearing down 2 concepts that have basically completely rewritten the playbook for developers: direct preference optimization, or DPO, in constitutional AI.
And, the shift we are looking at here is just monumental. Because for a really long time, the whole goal of alignment, basically making sure a model actually does what you want it to do, safely and reliably. It was this brute force effort.
Just throwing compute at the problem.
Exactly.
Yeah.
It was incredibly complex, highly specialized, and frankly, prohibitively expensive. I mean, only the largest tech labs could actually afford the hardware, not to mention the specialized PhDs required to even pull it off.
Right.
But what our sources map out today is this really fascinating transition. We're moving toward methods that are surprisingly elegant. And crucially, for anyone listening right now, they are actually accessible enough to run on standard infrastructure.
Which is huge. So let's start by unpacking that architectural nightmare I mentioned at the top, because to really appreciate the solution, I feel like we have to understand the pain of the problem first.
Oh, absolutely. Pain was very real.
Right. So historically, aligning a large language model meant you were wrestling with reinforcement learning from human feedback, or RLAIF. And usually that utilized this algorithm called PPO, proximal policy optimization.
Yep, the classic PPO setup.
And for traditional software engineers, reinforcement learning often just feels like dark magic. It's notoriously unstable.
Well, yeah, it is unstable because there's just so many moving parts competing for memory and compute all at the same time. Under that standard PPO setup, you aren't just running your main AI model.
Right, you've got a whole crowd in there.
Exactly. You have the main policy model that's the one you are actively trying to train, but then you also have a frozen reference model just sitting there.
Just taking up space.
Taking up massive amounts of memory, yeah. And its only job is to make sure your main model doesn't somehow forget how to speak English while it's learning new rules.
Which is crazy to think about.
It is. And then, on top of that, you have an entirely separate AI called the reward model. Its only purpose is to judge the outputs of the main model. And finally, yes, there's a value model to predict future rewards.
So that is 4 separate neural networks loaded into GPU memory simultaneously?
4 massive models, yes.
I mean, as a developer, the analogy that immediately comes to mind is like trying to build a core application, right? But just to know if your app is working, you have to build and maintain this massive, complex, external microservice.
That is exactly what it feels like.
And that microservice's sole purpose is just to constantly evaluate your main app. So now you have to manage its uptime, its latency, its infrastructure. And worst of all, the 2 systems have to constantly pass these enormous batches of data back and forth.
And the overhead for that is just staggering.
Yeah.
You're suddenly managing multiple distributed systems just to train the one piece of software you actually care about. And the really fragile part is, if that reward model gives a slightly weird gradient like just a strange piece of feedback, the PPO algorithm can over-optimize and completely shatter the main model's underlying logic.
Oh, wow.
Yeah, we call that policy collapse. It just breaks.
Which is terrifying after spending all that money on compute. Which brings us to the first major breakthrough in our notes today. Direct preference optimization, DPO.
The game changer.
Literally, because according to the research, DPO achieves alignment by mathematically specifically, algebraically eliminating the need for that separate reward model entirely. It just completely deletes that massive microservice.
Well, it doesn't just delete it, it actually absorbs its function.
Okay, explain that.
So the researchers behind DPO realized something really brilliant about the math of reinforcement learning. In the old system, you trained a reward model to score responses, right?
Oh.
And then you used RL to maximize that score.
You're trying to get the high score.
Exactly. But the DPO paper proved that you can mathematically map the optimal policy directly to the human preferences. You could just bypass that whole reward model phase completely.
Okay, let me make sure I am really wrapping my head around this. Because if DPO doesn't have a reward model to output a score, like there's no secondary system saying, I give this response an 8 out of 10, how does the loss function actually know what to optimize?
That's the clever part.
Like, how does it actually adjust the weights?
It looks at the probability differential. So instead of guessing a reward score, DPO takes a pair of responses to the exact same prompt, one that a human preferred and one the human rejected.
Okay, a winner and a loser.
Right.
Great.
And it looks at the log probabilities of the exact tokens in the good response, and it increases those probabilities. And then, in the exact same mathematical step, using a single cross-entropy loss function, it heavily penalizes the tokens in the bad response.
Oh, wow. Okay, that makes so much sense. So it is kind of like taking the core validation logic that used to live in that clunky external microservice and just baking it directly into the compiler itself.
That is actually a highly accurate way to visualize it, yeah.
Yeah.
By doing this, DPO takes what used to be this fragile multi-model reinforcement learning loop, and it turns preference optimization into a simple classification problem.
And I gotta say, hearing the phrase classification problem is the absolute ultimate relief for an engineer.
Right, because it operates exactly like standard supervised learning, which everybody knows how to do.
Totally familiar territory.
Exactly. You have inputs, you have preferred outputs, and you just train the model to map one to the other directly. There's no dynamic generation happening during training, no secondary models to balance in memory.
You just update the main model directly based on the preference data.
That's it.
But, hold on. Nothing in software engineering comes without a trade-off.
Never.
It sounds perfect, right? Simplify the architecture, use standard supervised learning, skip the middleman. But our sources do point out a crucial distinction here. DPO is an offline method, whereas PPO is an online method.
Yes. And this offline versus online distinction is really the fundamental dividing line in modern alignment methods right now. It completely dictates how you structure your entire training pipeline.
So break that down for us, because obviously when we say offline in this context, we definitely don't mean like unplugging the server rack from the internet.
No. In machine learning, offline just means the model is learning exclusively from a static data set.
Okay.
So with DPO, you hand the model a pre-existing massive file of prompts paired with answers one chosen, one rejected. The model reads that static data and updates its weights. It is strictly studying the textbook it was handed, basically.
Got it. And online methods.
Online methods like PPO are dynamic. The model is actually generating brand new responses during the training loop itself.
Oh, so it's live.
Right. It spits out a paragraph, hands it over to that separate reward model we talked about, gets a score back, and then adjusts its behavior on the fly based on that score. It's actively exploring the landscape of possible answers, trying new things to see what scores highest.
Okay, so the trade-off is basically stability versus exploration. DPO is much simpler to implement, and it won't suffer from that policy collapse because it's not guessing wildly.
Exactly.
But it is fundamentally limited by the edges of that static data set. It can't just try a new approach and learn from it dynamically.
Which means the performance of a model trained with DPO is bottlenecked entirely by the quality, the size, and the diversity of the preference data you feed it.
And that leads perfectly into the massive hurdle the industry had to clear next. DPO is brilliant, right? It relies entirely on a static data set. But ironically, that is also its Achilles heel.
Yeah, you fix one problem and create another.
Exactly. You've solved the complex math and architecture problem, but you have just created a massive data problem. If DPO needs hundreds of thousands of paired examples, like prompt X, response A is better than response B, how do we solve the bottleneck of getting human beings to sit around reading and labeling all those model outputs?
Well, historically, you hired armies of human labelers.
Literally armies.
Basically, you would have these giant spreadsheet factories where people read two slightly different AI responses to a really complex coding question or maybe a legal query, and they had to click which one was better.
That sounds mind-numbing.
It is excruciatingly slow. It costs an absolute fortune. And frankly, humans are incredibly noisy data generators.
Noisy meaning like inconsistent, because, I might think a response is great because it's super detailed, but you might rate the exact same response poorly because you think it's way too verbose.
Exactly. Plus, human attention spans degrade over time. A labeler at 9 a.m. on a Tuesday gives very, very different feedback than that exact same labeler at 4:30 p.m. on a Friday.
The dreaded Friday afternoon slump.
The data set just becomes incredibly muddy.
So how do we fix this? Because we need massive, high-quality, perfectly consistent data sets to feed this hungry DPO algorithm. And our notes point to the second major paradigm shift here, constitutional AI.
Right. Constitutional AI is a really profound conceptual pivot because instead of relying on vast amounts of human effort to label thousands of granular, localized comparisons, it shifts the human effort entirely.
It moves it up a level.
It moves the human element up to the macro level. So instead of labeling the data one by one, humans write a small, clear set of overarching principles, a constitution.
You know, to bring this back to a developer's perspective, this feels exactly like the shift from writing thousands of brittle unit tests to defining a core set of business rules.
Oh, that's an interesting way to put it. Walk us through how you see that mapping out.
Well, okay, imagine you are trying to ensure your software handles edge cases safely. Right. The old way, the human labeling way, is like writing 10,000 individual unit tests. Like, if the user inputs exactly this string, make sure the output is exactly that string.
Right. Very tedious.
It takes forever to write, and the second a user tries something you didn't explicitly test for, the whole system breaks. It just requires constant, tedious human maintenance.
And importantly, it doesn't generalize well to new situations at all.
Right. But constitutional AI is like stepping back and saying, look, I am not going to write 10,000 granular tests. I am just going to define the core logic.
Yes.
You write a rule like, the system must prioritize user privacy and never output personally identifiable information. You define the constitution, and then you just let the system figure out how to apply it across millions of unique interactions.
That captures the dynamic perfectly.
Yeah.
But, the Constitution itself is really just a text document, the engine that actually makes those business rules execute autonomously, the engine that generates the data that is where RLAIF comes in.
Reinforcement learning from AI feedback.
Exactly.
Okay, let's pause there for a second. AI feedback replacing human feedback. Walk us through the actual mechanics of how that pipeline runs.
Sure. So once you have your Constitution, those core human-written principles, you still need to create that preference data set for DPO.
Right. The pairs.
But instead of paying a human to read 2 AI responses and decide which one better follows the rules, you use a large advanced language model to do it.
Oh, okay.
You literally feed the Constitution into the model as a system prompt. Then you show it the 2 responses, and you just ask the AI, hey, based strictly on these specific principles, which response is better and why?
Give us a concrete example of what one of those rules might actually look like in practice.
Okay, imagine one of your constitutional principles is, choose the response that is least helpful to a cyber attacker.
Good rule to have.
Definitely. So when the system is asked by a user how to breach a specific type of server, the main model might generate 2 potential responses. Response A gives a vague warning about security. Response B actually includes a snippet of vulnerable shellcode.
Yikes. Okay.
Right. So the AI grader uses that exact constitutional rule to evaluate both. And it explicitly downranks response B because it clearly violates the principle of not helping an attacker.
I have to push back hard here, though, because honestly, this sounds incredibly risky.
How so?
We are talking about using AI to grade AI on human values. That just sounds like a snake eating its own tail. Doesn't the AI just, reinforce its own biases? Like, how can we possibly trust a model to grade itself?
It's a really good question, and it is the most common and valid criticism of RLAIF. If the grader model has a blind spot, it will absolutely systematize that blind spot across your entire data set.
Right, it'll just bake the error in perfectly.
Exactly. But there are 2 main mechanisms preventing a snake from eating its own tail, as you put it. First, you usually don't use the same model to grade that you were trying to train.
Oh, okay. Different models.
Yeah. You use a massive, highly capable frontier model to act as the grader, and it generates the data to train a smaller, faster, cheaper model.
Okay, so it's more like a teacher grading a student rather than a student grading their own homework.
Exactly that. And second, the data from our sources shows something pretty remarkable about the Constitution itself. Because the AI is forced to read the principles and actually write out its reasoning before it scores the response, it anchors the model.
It forces it to show its work.
Right. And the studies in our notes show that these AI-generated preferences are now matching, and in some cases even exceeding, the quality of human labels.
Exceeding human quality. Wait, in what way?
In pure consistency. Because the AI never gets tired, it never gets distracted, and it definitely doesn't suffer from the Friday afternoon slump.
That is wild.
It applies the constitutional principle exactly the same way on the first prompt as it does on the 100,000th prompt.
Man, that makes the alignment process just massive and infinitely scalable. Like, you don't need to wait weeks for a data labeling firm to return a batch of CSV files, and you don't have to pay them $100,000 to do it. You can literally generate 1 million preference labels over the weekend just by running inference on your own servers for, what, a fraction of a cent per label.
Exactly. And if you think about the implications of that for a software engineering team, it completely changes the velocity of development.
Oh, I bet.
If you realize your model has a bad habit, say, maybe it is being too condescending in its tone, you don't need to commission a whole new human study. You just add a rule to the Constitution.
Choose the response that is polite and encouraging.
Yep. You run the RLAIF pipeline overnight to generate new data. You run DPO in the morning, and the model is fixed by the lunch.
That is incredible. The iteration loop goes from months down to hours. Which, brings us to the big picture here.
Oh.
When we put these pieces together, if DPO fixes the training complexity by giving us this elegant mathematical shortcut that runs on one model, and constitutional AI powered by RLAIF fixes the data bottleneck by just automating the labeling process, where does this actually leave the industry as a whole?
Well, if we pull back and look at the overall trajectory mapped out in these sources, the trend is undeniable. We're moving rapidly toward the total democratization of AI alignment.
Democratization meaning it is no longer just the wizards in the ivory tower who get to dictate how these models behave.
Exactly. The metric we discussed earlier perfectly illustrates this shift. We went from requiring 4 complex models, carefully balanced in memory by specialized reinforcement learning experts, down to just a single model using standard supervised learning.
It's a huge reduction in complexity.
And we went from millions of dollars in human labeling costs down to automated AI-driven pipelines based on a simple text document of rules.
And that right there is exactly why you, listening to this, need to care. Because this isn't just academic theory happening in some closed-off research lab anymore. This shift means that fine-tuning and aligning a large language model is actually becoming a standard toolkit.
It really is.
You can take an open-source model, write a constitution that fits your specific application's needs, whether you're building, a specialized customer service bot, a legal document analyzer, or a coding assistant. You generate your own preference data using RLAIF, and then you just align the model locally using DPO.
That entire pipeline would have been pure science fiction just a few years ago.
Totally.
It turns alignment from this bespoke scientific experiment into a standard engineering problem.
Yeah.
And as we know, engineering problems are solvable with good architecture and clean code.
Absolutely. So let's do a quick recap to synthesize all of this, because we really have covered some serious technical ground today.
We have.
We started with the realization that the old ways of aligning AI, specifically PPO, were bloated, requiring 4 separate models and just a constant battle against policy collapse.
A total nightmare for compute.
Right. Then we looked at DPO, direct preference optimization. It uses a brilliant mathematical substitution to completely bypass the need for a separate reward model. It looks at the probability differential between a good response and a bad response, and it turns a messy reinforcement learning problem into a clean, straightforward classification problem.
But of course, we noted the major constraint there. DPO requires a static data set. It is offline, so it needs massive amounts of high-quality preference data to work effectively.
And to get that massive data set without breaking the bank or waiting months, we explored the second major innovation, constitutional AI. Instead of humans doing the tedious micro-level labeling, humans define the macro-level business rules of the Constitution.
Exactly.
Then, using RLAIF, a larger teacher model grades the outputs based on those rules, generating the preference data automatically.
Which scales human principles cheaply, consistently, and incredibly fast, empowering literally any developer to align a model on accessible hardware.
It really is a completely new landscape out there. But, before we wrap up, I do want to leave you with a thought. Just a final, slightly provocative idea to chew on during the rest of your coding session.
Oh, I like where this is going.
So we talked about how we are now relying on AI to generate human quality preference labels based on a small set of foundational principles, right? That constitution we write.
Right.
But if the AI is becoming that good at understanding, applying, and even explaining those principles, how long before we start trusting the AI to suggest improvements to its own constitution?
Oh, wow.
Like, if it processes millions of edge cases and understands the contradictions in our rules better than we do, when do we actually hand over the keys to the rule book itself?
That is a very profound question of governance and control. And, while DPO is an elegant shortcut that skips the reward model entirely, there are still very valid, highly technical reasons you might actually want to build a standalone reward model anyway.
Wait, really? After all that?
Oh, yeah.
Which actually brings us to our next deep dive. Tomorrow, we are going deep into reward modeling. We will explore how to actually train a neural network to score outputs the way a human would, and perhaps more importantly, the surprising, sometimes hilarious, and often dangerous ways these models can be gamed by the AI they're trying to evaluate.
Okay, you definitely will not want to miss that one. It is going to be a fascinating look at what happens when this system figures out how to outsmart the task. So until then, keep building, keep questioning the architecture, and stay curious. Have a great night.